All right, so we're making some progress. So in this video, the plan is to basically get a low voltage AC. So in case you missed it in the last video, we have our solar panel, which goes into our charge controller, which charges our battery. And then from our charge controller, we get 5 volts coming out of the 5 volts DC coming out. We stick that into 2 diodes, which drops the voltage down, goes into an inverter, which produces us 120 volts AC voltage. Now that's way too high for me, and so I want to get it down to, 12 volts, 15 volts AC. Something safe that, if a kid, let's say an 8-year-old is using the kit and he shorts it out, then it's not going to be some explosive fireworks. That's the plan anyway. So in case you're not up to date, this is for my final year project. So I study electrical engineering. I just finished my 2nd year and I'm going into my 3rd year. And so the hope is that I can, for my final year project, design a kit that I can sell on the internet, and then that hobbyists and students can use that renewable energy kit to learn how renewable energy works, to learn how solar panels generate power, which then charge controllers, how they work, to then charge batteries, and also how they produce DC output, and then also how to create an AC output from that. And so it's going to be small little perf boards which people are going to be able to create their kits on by following my tutorial. So that's what the final year project is. I'll link up here now a link to the video where I go through my whole project plan. But what I'm doing with the summer period now, before I start my 3rd year, is I want to learn how all of this works. So I'm using commercial products. That's what I'm doing. So since I wasn't actually able to get a decent low voltage AC, either by using this inverter here, which again gave me 120 volts, or this one, which was just too powerful, too beefy, using a buck converter to get the voltage up to 12 volts, it drained my battery instantly. So that was no good. So what I'm going to do now with this video is, instead of using an inverter to create an AC output, I'm going to try and use a sine wave or a function generator. So this is just a function generator here, and the plan is to basically use this to generate hopefully 12 volts AC. So first, let me figure out how this works. I'll use just a standard power supply and see if I can get 12 to 15 volts AC or 12 to 15 volts sine wave out of this. And then if I can do that, then we can hook it up to the rest of the circuit. That's the plan. All right, so let's start with the Amazon listing for this. So it's called the U-Mile Signal Generator Module ICL 8038 Medium Low Frequency Signal Source 10 Hz to 450 kilohertz. Triangle Square Wave Triple Waveform Generator Module plus DuPont wire female to female and male to female 3 pins. Alright, so it says that it's a precision oscillating integrated circuit with multiple waveform outputs. The frequency and duty cycle of the output waveform can also be controlled by current or resistance. The frequency is controlled by current or resistance. Okay, good to know. By the chip has a FM signal input. It can be used to low frequency signal frequency control. Alright, all I want is a sine wave out of this. So it didn't come with any instructions or anything. Okay, operating voltage, there we go. That's what I was interested in. So DC 12 volts to 15 volts. So I got to put 12 volts, 15 volts into this, which is going to go into this input here. That's the input there, VCC and ground. So I need to use my buck converter again to boost the 5 volt voltage from this. So what I'll do is I'll just start off by just putting 12 volts in using my power supply, and then we'll go from there. I suppose the only thing to do is let's just stick 12 volts into it and then just tap our oscilloscope to the output and see what we get. Alright, so this is interesting. So I've set up my oscilloscope connected to the output here. The output is actually a little bit tricky because it says there AC, and then it says G for ground, and then DC. So there's literally 3 pins. So it'd be interesting to see if I can check if that just produces a DC output. And then on the input here, which is where the power supply is currently, there's all these jumper pins here. So you got the pins on this left side here. It's currently selected onto C5. So this is basically selecting, it has resistors there. I'm assuming this C3, C4, C5, C6, C7. Although, actually, if that's C, that's going to be capacitors, right? So, wait, C? Capacitors that small? I don't even know. I mean, I'm assuming that's capacitor. So changing this is going to change something. Perhaps it will change the type of waveform, or perhaps it will change the frequency. We'll check that. And then there's also jumper pins here, which I'm guessing this is actually going to change the type of waveform because there's only 3 of them. So I'm guessing it's going to be like, for example, sine wave, square wave, triangle wave, or something like that. Or maybe it's here and just changes frequency. But then we've also got all these potentiometers here as well. So I mean, I've literally got 3 options to play with. I've got these jumper pins here, these 3 jumper pins here, and then these 5 potentiometers. So I'm just going to turn on my power supply now. We'll turn on the oscilloscope, see what happens when we chuck 12 volts into this, just on these default settings as is. And then we'll start playing with stuff and see where we go from there. Again, you know, it's all a learning phase, and I would much rather learn like this than reading a 46-page manual on this. It's just how I am. Alright, so right off the bat, I noticed as I crank up the voltage here, there's an LED, this D12 LED that turns on. So at the moment you can't see it on 1 volt, but there you go, 2 volts, it's clearly visibly on. However, there is no signal on the output. So again, that's to be expected. It's supposed to work on 12 volts. I was just surprised that LED goes very bright at 4 volts, 5 volts. Still getting brighter as well. Actually, look at that. That's a very bright LED, 9 volts. So on our output, 11.7 volts is still nothing on our output. 12.5, still nothing on our output. Interesting. 13. I'm not going to go above 15. 14.3, still nothing. Let me press auto. Yeah, I mean, we've got nothing on the output. Okay, so I'm assuming we're gonna have to move some stuff around here. I don't know what we're gonna move around. Yeah, I got no idea. Should we just start playing with some stuff? Just I mean, maybe I could try turning some potentiometers. I don't know if that's gonna make a difference. My voltage on my power supply fluctuates a bit. Oh, we got some voltage. Interesting. I noticed as I was turning it, the power supply was reacting. Hey, we've got something there, look. We've got something. We've got a sine wave, a 1.45 volt sine wave at 22 kilohertz. Oh, this is brilliant. I don't know what that does or how that works. But get in there, man. Some progress there, people. Okay, so maybe alright, so this is reducing the frequency. So that's reducing the frequency. What does this do? Is this increasing the voltage or what? No, this is reducing the frequency even more. Alright, I'm guessing, you know, for example, one of these might be like a setting, one of these jumper pins. They might be like a settings pin whereby it's like, for example, you use this pin in order to go from 1 volt to 2.6 volts, for example. So what I'm thinking is if I increase this, if I take the jumper pin off and if I put it onto a different setting, I'm thinking it might jump up. So we'll move on to the second one. There you go, I was bang on as well. It's become a triangle wave now, but it's at 3.8 volts. Let's go up to the next setting. I mean, I don't want to read a book, but I would like some instructions. Like, give me something. Alright, so now this has come to a square wave at 6.85 volts. Okay. Well, I want a sine wave. That's what I want. So maybe it's sine wave, triangle, square. So let me try adjusting these. Hopefully these are the settings. Oh, what's that now? Okay, interesting. So on no setting, 4.7 kilohertz, kind of dodgy looking, kind of sine wave. Okay, we'll try the first setting. Oh, that's interesting. That looks like a decent sine wave right there. Oh, nice. That is a good looking sine wave. At 2.5 volts, 1.26 kilohertz. All right, let me try the last setting then. Alright, this is going to take me a while to figure out, so let me just play around with it and then I'll get back to you once I figure something out. Alright, so this is unfortunately the best that I can do. At most I can get 3 volts at 264 kilohertz. If I decrease the kilohertz, the frequency, then the voltage drops. And even this sine wave isn't the best. So I'm going to have to scrap this. I don't think this is going to work. I've actually got it on a DC output. I tried moving that around. If I go back to AC... can see I get the same thing basically. So I'm not sure what that DC versus AC setting does on the output, but yeah, there's nothing I can really do at this point. So what I can do is I'm going to try and use a different function generator. Now, I actually do already have a function generator which I built up in a different video, and this one works perfectly. I can't remember what the output voltage is. I'm pretty sure it's just 12 volts input. And I mean, it's just basically the same thing, isn't it? I mean, I'm sure I could just use that. It's just a much easier, simpler version, I'm guessing. So let me just try and do the exact same thing basically. This is a DC barrel input. Maybe it might make sense to just desolder that DC barrel input. So desoldering this shouldn't be too difficult. I just need to figure out what's going on with these two. So you can see here that these two are clearly connected in the PCB, and we can just check that using a multimeter to just take one of them. There, you can see they're connected. If I do it on here, I mean, it beeps very momentarily, but yeah, they're definitely not connected. I don't even know why it beeps momentarily. So yeah, which one's VCC and which one's ground? So how I can find out is I've got ground over here, right? So if I stick this into there like that, so I hold that onto the ground, and I could even just put it onto here. So that ground is holding on there, and then there you go. So these two are ground and this one's VCC. So I'm just going to desolder these and then tap a wire into here and then one wire into here, and we're done. I mean, to be honest, do I actually even need to desolder it? I don't think I do. Why does the DC barrel input have 2 grounded pins and 1 non-grounded pin? I actually don't even know that. So I didn't actually manage to desolder it. I tried my best, and instead I just tapped some wires through onto the pins there. So it worked out, and to be honest with you, I'm very happy. Have a look. So we've got 12.3 volts coming from our power supply going into our function generator over there, and then we've got an 8 volt 50 hertz or 49 hertz, should be 50, yeah, 50 hertz. So can I power anything with 8 volts AC? I don't know, and in the final kit I would like to figure that out, but you know, this thing can't produce more than 8 volts. 8 volts is its max, and I think when I eventually build my own, I'm going to have to learn, because I'm going to have to basically dig deeper into all of these circuitries and figure out, you know, exactly what's going on with the charge controller, figure out exactly what's going on with the function generator, and then adjust these components so that I can, for example, put 20 volts into this or 80 volts into this or whatever and get 12 volts out. Because I mean, if 8 volts AC, I mean, it's not AC, is it, but it's a sine wave. But if 8 volts is enough then to power something, then we'll use it, we'll go with it. I just want the purpose is for whoever's using the kit to learn what AC voltage is and how it works, right? And it's also for me to learn that as well. So yeah, I think that's it. I mean, I don't think there's really anything else that we need to do. The only thing now is, I suppose, just connect up the whole circuit, solar panel, charge controller, everything, connect it all together with the battery, and then you should be able to get from the output. I mean, because what I found is that the power supply is very different to the charge controller, and I don't know if that's a real thing or if that's just what I found so far. So let's quickly connect up the whole circuit and just confirm that we do still get 8 volts and 50 hertz out at the end. So I'm going to keep all the settings on the function generator the same, and then go from there. So yeah. Alright, so I've got the whole thing set up now. We've got our solar panel over here. We've got our solar charge controller, which is obviously solar panel to the charge controller into the battery, and then we've got from the charge controller into this boost converter, which is taking our 5 volts from the charge controller, 5 volts input, and is outputting 12 volts to turn on this function generator, which is perfect. And then from our function generator we have an output of, so it says 8 volts peak to peak, which is an RMS voltage of 4 volts. So I can't get any more voltage out of this thing. So since my second stage was actually to use DIY you know, kits instead of commercial parts. So this is a commercial part, right? You buy it and it just is like this. Same with the boost converter. So I'm gonna buy kit versions of these, but here, you know, this is already a kit version. So what I might do is I might buy another one and see if I can modify it to output a higher voltage. But at the same time, if all I can get is 4 volts from it, then I mean, it's something, you know. And I don't know if 4 volts AC is usable. I don't know if I'm sure I should be able to drive something with it. Do you know what I mean? Just to show that it works. But we'll see. But for now, I'm happy with this. You know, this right now as a project is working perfectly for me. So I think the only other thing to do now would be to just get a 5-volt output from our charge controller again to power another device, and then either also or slash both, don't know, but to power an Arduino or a Raspberry Pi. So I'd be intrigued to see if this charge controller could power a Raspberry Pi. We'll do that in the next video. I have a feeling it's going to be a bit harder than I think it's going to be. So yeah, for now, you know, I'm quite happy with this. This is tough, but this function generator can do sine waves, square waves, and triangle waves. So hopefully my own kit version should be able to produce a sine wave, you know, using, you know, a third of this size. And so it'll be, I'm really looking forward to seeing the final design. It might actually even be cool to just have the whole project, basically a charge controller with a boost converter with a sine wave sine wave generator, all on one board. I like that. Again, this is exciting times. So yeah, cool guys, thanks for watching. If you enjoy it, leave a like. And yeah, man, I'm thoroughly enjoying this. So cool. I'll see you in the next one when we try and get a Raspberry Pi. I mean, I can use an Arduino, and I think an Arduino might be easier because I could, for example, put the Arduino in the kit itself. So maybe an Arduino we'll use, but if not, then we'll go with a Raspberry Pi. I like the idea of using a Raspberry Pi as well. And I mean, the Raspberry Pi Picos are very cheap, but I think maybe like a Raspberry Pi Zero. We'll go with either Raspberry Pi Zero or we'll go with an Arduino. Cool. See you guys in the next one.